All right, welcome AP. Last video in chapter 6. Let's look at some acid-base behavior based off of their chemical structure and how many oxygens that they have. So we have two different rules. So factors that affect acid strength, they can be a binary acid, and what binary means, two elements. And because we're talking about acids, we know it's an H with a nonmetal in the back, okay? With oxyacids, we know that these are more than two elements, okay? So like you would see H with a polyatomic, but because it's oxyacid, that polyatomic contains obviously oxygen, okay? So let's deal with the binary first. This H and X, that bond, that line that's between them, that's called a bond. And in that bond, they are sharing two electrons. Now, those electrons can be far apart from each other or very, very close to each other depending on size of that nonmetal. So that X being that nonmetal, the bond strength tends to decrease as the nonmetal increases. So basically, like if I took, we'll look at a group trend. So fluorine, chlorine, bromine, these are all sitting on top of each other. So you're looking at fluorine, that's got, 9 electrons, and chlorine has 17 electrons, and bromine, I think at 35. Okay, the more electrons they have, the distance between that nonmetal and H gets bigger and bigger and bigger. Okay, so the acid strength increases down the group. Okay, so we're only looking at the acid strength. The base strength actually goes the other way, but the base strength, we would be looking at group 1 and 2 on the metal side. Okay, so we're just looking at the acid strength. So the acid strength increases down the group. So your explanation for why the acid strength tends to decrease is you have to look at the distance in that bond between the H and those electrons. So the bond strength, which is keeping those electrons close together, decreases in strength as the X, the size of that nonmetal, increases. So the bond strength decreases down the group, which means as you go down, the bond strength gets weaker and weaker. And why? Because the distance between the H and that nonmetal is further apart. Okay, so the acidity of that acid, the strength of the acid will increase as the bond strength decreases. Okay, so as you go down the group, we just said that the bond strength decreases and the acid will get even stronger and stronger because the distance between them is even further and further away, because you can break the bonds much easier when they are further apart. So we call this, it's called delta H bond enthalpy. You're going to learn about this in chapter, chapter 8, bond enthalpy. Because the distance between like maybe H and F, and we'll actually put H and F, is closer together versus somebody like HBr, bigger distance from each other. Because that distance between each other is further away, this is weaker, which means the acid is stronger because I can break that bond much easier. Okay, so when you're looking at a group, you got to look at the size of the atom. Okay, so remember when we do chapter 7, okay, we'll do a little periodic table. Probably helps if I draw it a little bit better. So what is the trend? What is the trend for size? So for size of the atoms, they get bigger towards the metals. And the reason why, and we look at this in chapter 7, has to do with something called Z effect, effective nuclear charge. And as you go down the groups, they get bigger and bigger. And why? Because of orbitals. Okay, so when we get to chapter 7, you're going to know what I'm talking about there. Okay, what happens? So this right here, this is a group trend. Okay, but this is your Y. Okay, HF, the bond polarity, and we talked about bond polarity, chapter 11. Okay, is important in determining the acid strength in a period. So this is a period trend. Remember, period going across. So if I was looking at period 2, which has, nitrogen, oxygen, and fluorine sitting right next to each other, okay, what's the trend? Well, the acid strength increases. Like I said, we're not looking at the base strength right now. The acid strength increases from left to right, which means as you go this way, the acids are stronger. And as you're over here, the acids are weaker. So acid weaker, acid stronger. Okay, and why? Because electronegativity. You have nitrogen, and I'll do it in a different color. Electronegativity, remember that is the ability, it's a scale, the ability to attract electrons. Okay, who wants electrons the most? Fluorine wants the electrons the most. Fluorine has the highest electronegativity value, 4.0, and then 3.5, and then 3.0. So the acid strength increases as the nonmetal's electronegativity increases. Okay, so how do you help with explaining? Well, the acid bond strength is important to determine the strength of the acid. The more polar the bond is, okay? Remember, hydrogen has electronegativity of 2.1 versus nitrogen, which is 3.0. Yeah, that's polar. But hydrogen versus fluorine, 2.1, 4.0. It's not only polar, but it's very polar. Because how do you figure out if something's more polar than the other one? It's the difference in electronegativity values. The greater the distance, the more polar it is. Okay, so the more polar the HF bond is, the weaker the acid is. So example, like HF bond is the most polar bond. So the energy required to dissociate HF into H and F is higher than that of any other halogen. Now I'm looking at the halogens, okay? So when you're looking at the halogens between H and Cl and Br, between H and F, that's very, very polar, okay? But between H and Br, okay, hydrogen's 2.1, I think bromine's around like 2.7-ish, 2.8, okay? I mean, it's polar, but it's low polarity, okay? So the more polar it is, the weaker the acid. That's why when you were learning the strong acids, who of these are strong acids? Well, HCl is a strong acid, HBr is a strong acid, but not HF. He is a weak acid. And why? Because its bond polarity is very, very polar. Okay. The other halogens, and then you got iodine down here too. Iodine, if I had to guess, it's probably electronegativity is like maybe like 2.4 or 5. That's not even polar as it is. Okay. But he's still a strong acid. Okay. So as you go across the period, it has to do with electronegativity. Okay, if you're looking at the group, you're looking at polarity. Okay, so that's to help you with the Y's. Okay, trust me, you're going to get practice on the next page. Binary is a little bit harder to explain than oxyacid. Oxyacid is the easier one. Okay, you're going to like this because it has to do with the oxygens. Okay, I always get the question, well, what about like if it has more hydrogens than the other? No, that has nothing to do with it. It's the oxygen. So many acids actually contain O and H groups. Okay, so acids that actually contain these OH groups, they're called oxyacids, obviously because they have oxygens that are in acid. So there's two trends. Very, very easy. For oxyacids, if they have the same number of oxygens, so notice right here, I picked 3 random ones, and they all have 1 oxygen, but the central atom is different. Okay, so if the central atom is different, what's the strength? So the acid strength increases, it gets stronger, as the increasing electronegativity of that central atom. Well, notice who this central atom is. So chlorine, bromine, and iodine. So what do we remember about electronegativity? So fluorine, chlorine, bromine, iodine. Electronegativity increases as you go up. So increasing electronegativity of the central atom increases acid strength. So that Cl being a higher electronegativity central atom, then the iodine is a lower electronegativity value. This is why that HCl is a stronger acid. Okay, so this right here would be a stronger acid than the HI. I'm just going to say weaker acid. Okay. Same thing if you were looking at electronegativity if you're going this way. Okay. So like if you had nitrogen and oxygen, remember electronegativity goes across. Okay. Gets bigger as you go across to fluorine. Fluorine is the most electronegative. Okay. Well, that should have been pretty easy, and this one's going to be even more easy. What if you have the same central atom, but now different number of oxygens? Okay, you're going to like this. Acid strength increases as the number of oxygens increases. You have 4 polyatomics with oxygen and chlorine, but the number of oxygens are different, but they're all chlorine. Okay, what do you notice about 2 of these? Right here. These 2 are strong acids. Okay, they are part of the 7 strong acids. Not these guys. They're weak acids. Okay, so as long as the central atom is the same, then you look at the number of oxygens. The more oxygens it has, the stronger the acid. Okay. When we're looking at strength, we can't be looking at 2 different things. Like I can't ask you like HCl, let's just say O2 versus HBr, maybe like O3. The central atom is different and the number of oxygens are different. We can't compare that. There's too many different possibilities. Okay. So when AP is asking you to compare, something is always the same, something is different. Okay, so what I want you to do is you have 4 practice problems. Okay, which of them is the more acidic acid? Okay, so these first 2, if you notice, you have an H and an element. This is binary. I always like to write down first what category am I looking at. These 2 on the bottom, these are oxyacids because it's an H and a polyatomic. So these are oxyacids. So when you're trying to figure out which acid is going to be stronger, you have to go back to the rules. Okay? So which one is it? So number 1, is it binary versus oxyacid? Now I'm going to help you with the first one with the explanation. Number 2, okay? Sometimes with binary, are you looking at a group trend or are you looking at a period trend? With oxyacids, are you looking at the central atom that's different or are you looking at the number of oxygens that are different? Okay, so for this one as binary, we're looking at between bromine and fluorine. So I already know I'm looking at, and I like to do little sketches on my paper. So fluorine, chlorine, and bromine. Okay, which one's going to be the more acidic? Well, I already know this is a no-brainer, but you can't say this. Well, HBr is a strong acid and HF is a weak acid, and then he wins. No, but nice try. Yes, this will be the answer, but what are we looking at? We're looking at a group trend. Okay, so first you need to say something about both of them. HBr and HF are both binary acids. Okay, all right, so they're both binary acids. Now, why is HBr going to win? HBr is more acidic. Remember, AP says you have to mention the other one. Then HF, since. So now, what is our evidence? Okay, our evidence is, let's look at the group. Okay, so in a group trend, we have bromine that has more electrons than fluorine. So that means the bond strength for HBr is weaker. And the weaker the bond strength, the more acidic it is. Okay, you literally have this right here. So I'm going to copy it so that way we can put it into our words. So that way we have it. Okay, so since the bond strength in HBr is, we can say weaker. You could even say the bond, and I'm going to put it in a different word. You could say the bond distance instead of talking about strength. The bond distance in HBr is, you could say, longer. Okay, some of you may think about the distance versus the strength first. Either one is fine. Okay, so the bond strength in HBr is weaker. So therefore, the weaker the bond strength, the stronger the acid. Okay, you don't ever want to mention trends. Don't say the bond strength decreases down a group. Don't mention trends. That's just how you figure out the answer. This is your evidence. Okay, this is why it does it, but that's your evidence that you need. Okay, so for P and S, you're going to notice that P and S, they sit right next to each other. So we're looking at a period trend. Okay, so look right above. And then we have C and D, where you have the same central atom, but different number of electrons. So you would be mentioning that both are oxyacids, okay, with the same central atom, but different number of oxygen atoms. So now you're going to hit them with who's going to win. Okay, so is it going to be the HNO2 or the HNO3? Well, I think we know. Okay, so HNO3, and yes, this is also a no-brainer. That's a strong acid. That's one of the 7 strong acids. He's not. Okay, so HNO3 is a stronger acid than HNO2 and Y. What's your Y? Okay, in this case, you have a different central atom, but the same number of oxygens. Okay, so you're going to write this first sentence, but you're going to change it up. You're going to say the same number of oxygen atoms, but a different central atom. Who's going to win? Okay. At the end, as always, we have practice AP pre-response questions. Okay? Hopefully not too bad this chapter, but chapter 17 is part 2 of acids and bases. See you on the next one.